All right, so let's see that in practice. I've got the rules for HillHuntington method here in bullets, but let's talk about a hypothetical country of 3 states with 40 seats in their Congress or their House of Representatives. So again, we're going to take the total population to find the standard divisor, and I'm going to abbreviate standard divisor this time. So standard divisor is the first thing I'm calculating, is equal to 2,640 divided by 40. So 2640 divided by 40 gives me 66. I'm going to take 66 and I'm going to use that standard divisor to calculate my standard quotas. We're going to divide every population of the individual states by 66. So I get 8.33, I get 2.42. For state B, 160 divided by 66 is 2.42. State C, 1930 divided by 66 is 29.24. Adding that up, just to make sure we haven't made a calculation mistake, I'm at 39.99. Again, it should be getting us to 40, but that's really darn close. That's just from round-off error. And that's fine. If I had gotten a 37, I would be concerned that I had made a mistake. Or if I had gotten a 43, I'd be concerned because that's quite a ways away from 40, whereas 39.99 is really, really close. And so that can be attributed to round-off error. Now, what we want to do next in the method is find the geometric means. Now, each geometric mean is calculated separately based on the number that we're dealing with in terms of this standard quota. Now, to help us out, I'm just going to remind you what we're going to use are the whole numbers on either side of the standard quota. So the standard quota, the whole numbers on either side are 8 and 9 in the first one, 2 and 3 in the second one, 29 and 30. So the two numbers on either side of the decimal. And what we're going to do to find the geometric mean is we're going to multiply those two numbers together, 8 times 9, and then we're going to square root it. So in this first one, we're going to get the square root of 8 times 9, which is 72, which is equal to 8.49. Now, I don't have a whole lot of room here, so I'm kind of talking through it and writing some of it down. But on the next ones, let's just go ahead and do that again. 2 times 3 is 6, and then I'm going to square root 6. So I get 2.45. And again, I'm rounding at the second decimal place. And then 29 times 30, that's a much bigger number, and I'm going to square root that and get approximately 29.50. And I left that one off just because it's hard to fit in right there. So I left off some of the calculations. But again, it's 29 times 30, and then you square root that, the result. So you get 29.50. Now, we're never going to add up the geometric means because they don't make sense to add up. The geometric means are just there for a boundary for rounding. Now, to make things a little clearer, I'm going to erase some of what I have here. Okay, because I just want to look at comparing the standard quotas with the geometric mean and figure out how to round them. So what we want to ask ourselves is our standard quota lower or higher than the geometric mean? If it's lower, then we round down. So the standard quota in the first one for state A is 8.33. That is lower than 8.49, so we round down to 8. 2.42 is also lower than its geometric mean of 2.45, so we round down to 2. And 29.24 is also lower, so we round down to 29. So in this first example, everything rounded down. Sometimes that happens. So 8 plus 2 plus 29, our rounded quotas give us 39. And 39, we wanted 40. Remember, that's too small. And what we've been doing is the rule for dealing with modified divisors is if we have a total that's too low, we're going to pick a modified divisor that is lower. Our next modified divisor needs to be lower. So I was using 66, so when I go to do this again, I'm going to use a modified divisor that's got to be lower than 66. So maybe try 64. So I'm going to make it go down a little bit. I'm going to try 64. So if I try 64, I'm going to repeat this whole process. I'm going to start with the populations. I'm going to divide each population by that modified divisor of 64. So 550 divided by 64 is 8.59. 160 for state B divided by 64 is 2.50. And then 1930 divided by 64 is 30.16. Now, here's one thing. You never want to add up modified divisors because they will not total. Because you're using a special divisor, they will not total up to 40. So we're not going to total anything after we get past the standard quotas in terms of the decimals. But we do need to now create geometric means to choose the rounding for. So our next thing in the table is to list out the geometric means we're going to use. Now, once again, we just look at the numbers on either side, 8 and 9. Now, we did this before over here with the standard quota, so this geometric mean is going to be 8.49, just like it was before. So if you recognize that your numbers haven't changed, that you're going to still be in the same range, you can still use them again. Here, we're going to be from 2 to 3, so that would still be the square root of 6, or 2.45. Things have shifted, though. When I was looking at geometric means with 29.24, I was using 29 and 30. Now I'm using 30.16, so I'm using 30 and 31. So we take 30 times 31 and we square root that new value. And we take 30 times 31 and square root, we get 30.50. So that one is different. So we did have to make one change. Again, do not do the sum for the geometric means. The geometric means are used purely for judging whether we round the up or down. So now, let me erase some of my markings here so we can clearly see the modified quotas. And what we're going to do is judge whether we round. So 8.59, is that higher or lower than the geometric mean? Well, it's higher. When it's higher, you round up. So we're going to go up to 9. 2.50 is also higher than its corresponding geometric mean, so we go up to 3. And our final value of 30.16 is lower than the geometric mean of 30.50, so it rounds down to 30. So when we take these rounded quotas and we add them up to see if we have the correct total number of seats, 9 plus 3 plus 30 is 42, and that is too high. So we're having to play this, too hot, too cold game again. Too hot, too cold. We want to find the modified divisor that gets us just right, the values that are just right. So we were too small when we used 66. We were too high when we used 64. So now we need to, if we're too high, remember if our total is too high, we're going to go higher. So I need more room. Let's go to the next slide. So with the standard divisor of 66, we found that the rounded quotas totaled up to 39, which was too low because remember we wanted 40 seats. And with the modified divisor of 64, the rounded quotas were too high. We got 42. So we want to use something between 64 and 66. Now 66 got us closer. 39 was closer to 40 than 42 was. So I'm going to stick with something that's closer to 66. I'm going to try 65.5 as my next modified divisor. Now you can choose whatever you want. Just it makes sense to actually try to be a little bit focused in terms of what might get you closer. And sometimes you'll get it right, sometimes you won't. Now, to use this as our new modified divisor, we're going to take each population and divide by 65.5. So when I divide state A's population of 550 by 65.5, I get 8.40. And when I divide 160 for state B by 65.5, I get 2.44. When I divide state C's population of 1930 by 65.5, I get 29.47. Again, we don't add up modified quotas. You should be able to just look at those and see that they're close to the standard quotas. It should be similar, but not the same, and that should give you a sense of whether you're on the right track. But the total isn't going to come up to 40 because we're modifying our divisor. Next, we'll find geometric means for each of these. Luckily, each of these modified quotas are similar to our standard quotas, since they will have the same geometric means because they're on either side of the same whole numbers. So our geometric means for 8 and 9 will be 8.49. For 2 and 3 will be 2.45. So we could just take this from earlier in the earlier slide. And then for 29 and 30 would be 29.50. Again, I'm just taking those from what we'd already calculated on the previous slide for our standard quotas. Now, we're going to compare the modified quotas with geometric means. If the modified quota is lower, like the first one is, we round down. So 8.40 rounds down to 8. Our second modified quota, 2.44, is also lower than our geometric mean, so we round down to 2. And then 29.47 is also lower than the geometric mean of 29.50, so we round down as well on that one, so we're down to 29. We add those up. 8 plus 2 plus 29 gives us 39, which is too low. I didn't go far enough in terms of going down below 66. Remember, 66 was too high. I needed to go lower, so I went to 65.5. Let's drop it down just a tad. Let's do our next try at 65.4 instead. So we've got 65.4. We're going to divide every population by that value to get our new modified quotas. So 550 divided by 65.4 gives me 8.41. 160 for state B divided by 65.4 gives me 2.45. 1,930 for state C's population, when I divide it by 65.4, gives me 29.51. Our geometric means stay exactly the same because we're still dealing with the whole numbers that are the same. 8 and 9, geometric mean of that is 8.49. 2 and 3, our geometric mean is 2.45. 29 and 30, our geometric mean is 29.50. Now, several of these comparisons are really easy. 8.41 is lower than 8.49, so we round down there. So in our third column, we're going to round. And then our last value, 29.51, is higher than 29.50, so that rounds up to 30. But these other two values, 2.45 and 2.45, are exactly the same, so we need to figure out what to do there. Well, remember, we rounded these values off, so what we should probably do is go back and recalculate them out further to further decimal places. So if I calculate this out, 160 divided by 65.4, and I take it out 3 decimal places instead of just 2, I get 2.446. So that's from taking 160 and dividing by 65.4 and taking it out 3 decimal places. And then I can do the same thing with the geometric mean. The geometric mean was from the square root of 2 times 3, which is the square root of 6. If I take that out 3 places instead of 2 places, I get 2.449. So now we can actually see a difference. Before, they both rounded to 2.45. Now we can see that the modified quota is lower. 446 is lower than 449. So that means that 2.446 rounds down to 2. And now we actually can add up our 3 quotas for our states, our rounded quotas. 8, 2, and 30 gets me 40. And that's perfect. We wanted the 40, and that's what we got. There's our 40 seats. So state A gets 8 seats. State B gets 2 seats, and State C gets 30 seats. So we now have an apportionment using HillHuntington method for this example. Again, with HillHuntington, we use the geometric means to round instead of the standard rounding rules.